Hello, welcome back. We're going to cover our last section on adding and subtracting radicals. And in this lesson, we're going to introduce variables into the problems. So for instance, 2 times the square root of 49x cubed, all of that stuff is under the square root. And we're subtracting from that 3, and then we have 16x to the fifth, and the radical is going to stretch over all of that. So the question is, how do we simplify this problem fully? Well, obviously we want to subtract them, but this, what's underneath this radical, is completely different than this, so we really can't do any subtraction. So the best bet that you really have is to try to simplify these radicals as much as possible and then see if you can combine things down the road. When you get everything as simple as you can, then either they are able to be combined or they are not, and you don't have much control over it. You just try to simplify them as much as you can to see how far you can go. So let's just take a look at what's underneath this radical. Well, the 49 can be written as 7 times 7. 7 times 7 is 49, and that's a pair, so I know I'm going to be able to pull that out. Now the x cubed can be written in the tree as x times x times x, right? And I'm looking for pairs, so I know I'm going to be able to pull out a 7, and I know I'm going to be able to pull out an x. So that's good. Now I'm not going to do it yet. Let's move on to this. Right? Let's go ahead and try to see if we can figure out what's going to happen here. Now the 16, you have lots of choices, but I know that 4 times 4 is 16. And since that's a pair, I'm just going to stop. I don't need to break the 4's down anymore because once I circle this pair of 4's, they can kind of come out and they're not really under the radical anymore. Now the x to the fifth, you can do it a number of ways, but let's just write it as x times x times x times x times x. You can draw these lines if you want to, but basically it's x times itself 5 times. Now, you want to circle pairs, right? So you can pull a pair out there and a pair out there. So you'll have one single x under there. So let's go ahead and continue on this direction. Now, from the first term, we have a 2 out in front, but that's now going to be multiplied by whatever we can pull out from here. So we'll pull out a single 7 and a single x. So the 7x will be pulled out like that. So pull out a single 7 and times a single x. Now underneath the radical here is going to be whatever's left over, which is, in this case, the single x that we had. The single x is going to remain under that radical. And then the minus sign, of course, is coming from here, and then we have a 3 out in front, which is from the original problem, times whatever we can pull out from here. We can pull a single 4 and 2 x's out, all multiplied together. So it'll be times 4 times x times x. Those are the two x's. We have a single x that's going to remain behind underneath the square root. So already I like this a lot because I noticed that, I have a bunch of junk out in front, but I have a square root of x and a square root of x. So those are nice because at least they match at this point. So let's go ahead and multiply this. 2 times 7 is going to give you 14. Let's go ahead and do it below here. 14x, that's what's outside of that radical, times the square root of x. We have a minus sign. 3 times 4 is 12, and this times this is x squared. So it's going to be minus 12x squared times the square root of x. Now, honestly, if it were me, I would just circle this answer. All right, that's totally fine to do. But you might look at it and say, well, I have a square root of x and a square root of x. So it is true that you can subtract these because they are like terms. But the problem is when you subtract like terms, what you're doing is you're subtracting the coefficients. But notice that this term is an x, 14x, and this term is 12x squared. So even if I subtract the coefficients, I'm still not going to really be able to subtract